Hello friends, so in today's question we are going to discuss today two questions. First is on block A 5 kg rest over another block B 3 kg placed over a smooth horizontal surface. There is friction between A and B. A horizontal force F1 gradually increasing from 0 to a maximum is applied to A so that the blocks move together without relative motion. Instead of this, another horizontal force F2 gradually increasing from 0 to maximum is applied to B so that the blocks move together without relative motion. So then we have four options, and these are two cases. In the first case, force F1 is applied on A. In the second case, force F2 is applied on B, and there is given that there is a force of, rather we can say there is a friction between A and B. So let us say there is a coefficient of friction mu between A and B. In both the cases it is same. So let us consider case 1. Case 1 is our figure. Let us A figure and B. So case 1 is figure A. A force is being applied on A, which is 5 kg. That force is F1. There is friction between A and B. So let me draw B. B is 3 kg. So this A will try to move B along the direction of force without the friction, and let us call that friction is Fr, and equal and opposite will be acting on A, that it will be all equal to Fr. And it said there is no relative motion between A and B. Okay. So we assume that they both are moving with the same acceleration A. Okay. It's given as there is no relative motion between A and B. They both move with same acceleration which is given as A. So if they are moving with same acceleration, so this will be 5 plus 3, and force F1 is being applied on it, and acceleration is A. So from here we can say A is equal to F1 upon 8. Okay. So let us draw individually for A and B. Okay. So for block A, first let's do for block A. So we have a which is 5 kg, F1 and Fr, and acceleration A. So from here you can write the equation that F1 minus Fr will be equal to ma. Okay. We already know value of A is F1 upon 8 and m is 5 kg, so this will 5 F1 upon 8. So we can further solve it. We can write that F1, taking it as common, so this will be 1 minus 5 upon 8 is equal to Fr. From here we can say that our F1 is equal to 3 upon 8 Fr. Now F1 will be maximum when equivalently we have our Fr as maximum. Okay. from here we can say that F1 max is equal to 8 upon 3 FR max. Okay, let us call this equation number 1. Now let us consider case 2. Force is being applied on B block. So this is A of 5 kg, this is B 3 kg. F2 force is being applied on the block B. So F2 will try to move block A, let us suppose with the friction Fr. So equal and opposite here will be Fr. Once again there is no relative motion between these two. Okay. So this is for figure B. So as there is no relative motion, we assume that both A and B move with acceleration A. So once again A will be same, A will be equal to our F2 divided by 8. F2 divided by 8. So let's write for block B. For block B, B of 3 kg moving the acceleration A, we have Fr and we have F2. So in the opposite direction. So direction will be in this direction, Fr. So we can write this as F2 minus Fr will be equal to MA. M is 3 and acceleration is F2 by 8. So we can solve this further. This is F2 taking as common, 1 minus 3 by 8 is equal to Fr. Here we can say our F2 is 518 is equal to Fr, and once again we can write that our F2 max is equal to 8 upon 5 Fr max. This is equation number 2. Now we here have two options, rather 4 options. First is it states that both are equal, which is not possible. Okay, either it will be greater than or smaller than. So if we compare F1 max and F2 max, let me write it here. Our F1 max is equal to 8.3 Fr max, and F2 max is here only. F2 max is equal to 8 upon 5 Fr max. So from here we can clearly say that our F1 max is greater than F2 max. In the second part, it is also asked what will be the ratio. So we can find out ratio as F1 max divided by F2 max, which will be coming equal to as 5/3, or we can write 5:3. So we have option number B and option number C is the correct one. So this completes the first question. So we have now second question, which states that a block of 7 kg is placed on a rough horizontal surface and is pushed through a variable force F as 5t, where t is in second, at an angle of 37 degree with horizontal as in figure. The coefficient of static friction of the block with the surface is 1. If the force starts acting at t is equal to 0 second, find the time in second at which the block starts to slide. So this is a figure. So in this case, we can divide this force into two components. This is force F. This angle is given at 37 degree. So we are going to F cos of 37, and we have F sin of 37, and block weight is given as 7 kg, and so we are going to have mg in the downward direction, and there will be corresponding normal in the upward direction. It is also given that the coefficient of static friction, so we can say the force of friction is opposite in this direction, that is Fr. So we can write our Fr will be equal to mu into net force in vertical direction. So this can be written as Fr equal to mu. This will be equal to our n minus F sine of 37 degree. Sorry, not n but mg, my mistake. Okay, this will be mu into n, that is net force. So that n will be equal to mg minus f sine of theta. Now we have, as soon as the block is going to start to move or slide, so under the sliding condition, you can say under the sliding condition, we are going to have that our applied force, that is F cos of 37, will be equal to Fr. Okay. We can write this Fr max also, doesn't matter, because this will be Fr max under sliding condition. So we get this as mu into mg minus f sine of 37 degree. The force is given as 5t. You can say 5t is equal to mu is given as 1. So we open this, we can write this as mg minus excuse me, f is 5t, sorry, 5t cos of 37 is equal to mu is 1, so it will be mg minus 5t sine of 37 degree. So we can write this as taking t as common. This will be, or rather 5t as common, cos of 37 plus sine of 37. M is given as 7 and G is asked to be 10. So we put the values. we get 5t cos of 37 is 4 by 5 plus sine of 37 is 3 by 5 is equal to 70. So this 5 goes with 5. This t will be equal to 70 by 7, or we can say t is equal to 10 seconds. Okay. So it means that t is equal to 10 seconds, the block actually starts to slide. Please complete the questions. Thank you.